How are y'all doing today? So what we're going to be working on today is we're going to be working on the shell model of an atom. Okay, so what exactly is that? Well, we've started working on the shell model, but you just don't realize it. So what we're going to do is we're going to do a quick review of what an atom is and where the protons, neutrons, the subatomic particles are located, and how to tell how many that there are. And then we're going to get into drawing the shell model. So, oops, excuse me. Sorry about that. So, let's start off by drawing a general picture of an atom. Let's label the protons, neutrons, and the electrons. Okay, the protons and neutrons are located inside of the nucleus. So we'd have two protons, or however many we draw. So there's a couple of protons. And then we'd also have neutrons inside the nucleus. So let's draw neutrons in the nucleus. So this example has two protons and a neutron. And then we would have electrons going around the outside, flying around in this electron cloud. That's generally how we have introduced the atom to you. Protons and neutrons in the nucleus, and then the electrons flying around the outside. Now let's just quickly review. What was the charge for a proton, a neutron, and an electron? A proton's charge was positive, okay? And the symbol was P+. A neutron's charge was a 0, and the symbol for that was an N with a little 0. And the electron's charge is negative, and the symbol for that is a little E-. So let's finish up the warm-up here with how many protons and electrons does carbon have? Well, here's carbon right over here. So how many protons and electrons does carbon have? All right, well, carbon is element number 6. You can see element number 6 right here. And that is the atomic number. And so that means that atomic number directly correlates to the number of protons. So carbon has 6 protons. How many electrons does carbon have? Well, carbon is a neutral atom, and the number of protons equals the number of electrons in a neutral atom. And so we have 6 protons and 6 electrons. Let's take a look at calcium. How many protons and how many electrons does calcium have? Well, this is calcium right here. And let's take a look. How many protons and electrons does calcium have? Calcium has an atomic number of 20. So there must be 20 protons. It's a neutral atom. Notice there's no charge. So that means it must equal 20 electrons because the protons equal the electrons in a neutral atom. All right. So that was our little review from today. Watch it again if you need to review it. And then we're going to move on to our modeling of atoms. So what really is a model? Well, there's really no drawing that I can show you that truly shows what an atom looks like. It's just an artist's rendering what an atom looks like. So, but the general idea is this image right here. You have this little dot right in the middle, and that's where the protons and the neutrons hang out. Right there, and that little spot. And then flying around the outside, we have these electrons in these electron clouds. You have these electrons that are flying around. And they fly around and around and around. Most of this atom is made up of empty space. We're going to get into that's why radio waves pass through things very easily. And that, well, these electrons, they just fly around. Now, we don't know exactly where the electrons are, but we know the general locations of where these electrons are. And these general locations are called shells. And this is just where they're probably gonna be. And we'll stick with that. That's where they're gonna be. So let's take a quick look. So again, this is a visual representation of what an atom looks like. This is not real life. Again, it's just what an artist has kind of come up with scientists way back in the day. And these are called electron shells that we're drawing. And these electron shells are nothing more than visual representations of where the electrons are going to be. For example, this is electron shell number 1, electron shell number 2, electron shell number 3. And this first electron shell has 2 electrons that we could find. The next one has 8. The third one has 8. We'll talk about how we know how many numbers are on it. But these shells are not real. These shells are kind of locations, but the shells don't move like the planets. The electrons aren't moving like planets do around the sun. They have these very, very, very eccentric designs and shapes to where the electrons can fly around. And so it's just the location we can find electrons. So we could find 2 electrons on this first orbital, 8 here, etc. Now, there's nothing that's going to be found in between these orbital levels. You won't find an electron right here. Not going to happen. If you are getting on a ladder, if you guys have ever been on a ladder, or stair steps, it is not possible for you to stand in between the 2 steps. You're either on step 1 or you're on step 2. You're not hanging out on step 3. There's no way you're hovering up there. We're not doing that David Blaine thing where we're hovering around. So you're either on 1, 2, 3, just like the electrons. And this is where we can find these electrons. So let's move on. Let's take a look at how to draw these shell models of atoms. And this is where we're going to take up most of our time today. All right? So let's take a look. First, let's read the directions. And then we'll go over it again, and I'll go slowly with you. It says, the number of shells an element has, the number of shells would be these shells. These were the shells where the electrons are hanging out. So the number of shells an element has directly correlates or is equal to the row number on the periodic table. So if there's 1 shell, it's row 1. There's row 1. If there's 2 shells, we're on row 2. 3 shells, there'll be row 3. 4 shells, row 4, etc., etc. Okay? The maximum number of electrons in each shell will equal the number of boxes in each row, which means row 1 will have 2 electrons. Row 2 is going to have 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Row 3 is going to have how many electrons? 8 again. 1, 2, 3, 4, 5, 6, 7, 8. Row 4 is going to have how many electrons? It's going to have 18. So let's slow it down and let's take a look at that a little more slowly. So we have row number 1, and row number 1 is going to directly correlate to. Let's get rid of it. Let's make it a little bigger. It's going to directly correlate to orbital number 1. Row number 2 is going to directly correlate to orbital or shell number 2. And you'll notice I'm using different words each time because these things have different names for the same thing. Row number 3 will directly relate to orbital or shell number 3. Row number 4, am I running out of colors? Yep. Row number 4 is gonna relate to row number 4. And then row number 5, 6, 7, 8. These would all be different colors. And if you want, I guess I could show you that as different colors very quickly. All right? All right, so here we go. So here's our little color panel. So then we could, row of black. So row number 4 is black, right? Oops, oh, that's why. So there's row number 4. Row number 5, we can make brown. All right, so let's make that brown. Row number 6, I guess we can make that magenta. And then row number 7, what color can I use? Cyan? Fine. So each one of these, I'm not going to draw them all, but each one of these would directly correlate to a different row, okay? So again, row number 1, right? Orbital number 1. Row number 2, orbital number 2. Row number 3, orbital number 3. Row number 4, and then I need to have a brown, a pink, and a blue if I want to keep this going. So that is how this goes. The shells of an element directly are related to the row number on the periodic table. Now, how many electrons can we put in each shell? Well, that directly depends on what row we're on. So this is row number 1, and row number 1 can have 1, 2 electrons. So we could come down here. I'm going to change the color just to put it in there. So we could have 2 electrons. Row number 2 relates to orbital number 2, and we could have 1, 2, 3, 4, 5, 6, 7, 8 electrons on that second row, which means we'd have 1, 2. Yes, I'm putting these in a specific way. I'm putting them in these groups called pairs, right? And there's my 8 electrons. Row number 3, how many electrons is row number 3 going to hold? That's right. 1, 2, 3, 4, 5, 6, 7, 8. Row number 3 is going to hold 8 electrons as well. 1, 2, 3, 4, 5, 6, 7, 8. Row number 4 is going to hold 18. I am not going to draw 18 electrons on here, but in theory, I would need to if I was going to draw that all out. So again, the row directly correlates to the shell, and the number of electrons is the number of boxes that are on each row. All right? So, and you always fill the shells from the inside out. So you notice I started on orbital 1, then shell, or shell 1, shell 2, shell 3. And if there's no electrons in a shell, well, in theory, if I had no shells, no electrons, that shell would not be there. And I would take my little pen and I'd be like, okay, well, let's get rid of this guy because there's no electrons there. So we'll take them out. All right? Perfect. All right, so that's how that works. Those are the rules. So let's go through and let's make one of these. Let's draw one out. Let me start all over. So we'll get rid of that. So let's do boron. Let's take a look at boron. Whoa, mama. Let's get rid of that. Let's shrink that pen down a little bit. Oh my gosh. Let's see. Oh my gosh. Let's go. There we go. All right. So let's take a look at boron. All right. So what row is boron on? So what row is boron located on? Okay, so boron is located on row number 2, which means that there will be 2 shells. So we're going to have 2 shells. And I'm going to put a B right in the middle to represent boron. Now we need to know, how many electrons does boron have? That directly relates to the number of protons. This is a neutral atom. There are 5 protons, which means there must be 5 electrons. So we're going to have 5 electrons. Let's draw some electrons in here. Well, how many electrons will we put on the first shell? 1, 2. Remember, the number of boxes in each row is the number of electrons on each row. There's 2 boxes, so we get 2 electrons. There's 1, 2. And now, how many electrons does boron have? It has 5. We've already used up 2, which means we have 3 left. And so that means we need to add 3. And look, 1, 2, 3. And those are all going to be on the second shell. 1, 2, 3. This juncture, you're good. You finished. This would be the answer of the shell model of boron. Okay? I can do another one. Want me to do another one here? Let's do another one. All right. Let's do another one really fast. All right, so what do we want to do here? Let's do another one. What do we want to do? Magnesium? Let's do magnesium. Let's look at magnesium. Okay, there's 12 electrons on magnesium, or 12 protons, sorry. I just gave you a bunch of answers. So there's 12 protons, means there's 12 electrons. We're on row number 3, so we're going to draw. Let me change the color back to red for you. We're going to draw 3 shells. There's 1, 2, 3. Those are pretty good. There's our magnesium. And we have 12 protons. So how many electrons? I already gave you that answer. 12 electrons. On the first orbital, how many electrons will be on this first orbital, the first shell? 1, 2. We're going to have 1, 2. The second one will have 8. We're going to have to draw that in. 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 2 equals 10, which means we have to get to 12. So we have 2 more, and those last 2, 1, 2, will be on the third shell. There it is. So we're going to do a couple of examples right now, and let's work out some more examples. So we're going to draw the shell models for the following atoms. Let's start with helium. All right, so where's helium located? There's helium right over here. Here's helium. So we're going to draw helium. What shell is helium on? What shell is helium on? What row is helium on? All right, and if we take a look, I'll put these numbers back in for you. You can see them, they're there. I'm just making these bigger for you. All right, so what shell is helium on? It's on shell number 1, which means that we're going to draw helium. Helium is going to get 1 orbital or 1 shell because it's on the first row. And then how many electrons does helium have? Well, helium has 2 protons. Helium is neutral. So 2 protons means 2 electrons. And we have 1, 2 electrons for helium. All right? So that's it. There's our answer. All right, let's take a look at the next one. Let's look at carbon. Here's carbon. Now, if you'd like to, why don't you stop the computer and try to draw carbon on your own. So carbon is on the third row. No, what row is carbon on? Second row. It means it's going to have 2 orbitals. I'm going to start off by putting a carbon. I'm going to draw orbital number 1 and orbital number 2. And how many electrons does carbon have? Well, carbon has 6 protons because that's its atomic number. And that will equal the number of electrons because this is a neutral atom. All right, so there's our neutral atom. So we have 6 electrons. All right, so what are we going to do? Oh, I apologize. I put those 2 next to each other. I usually put them opposite each other on the first one. I'll fix that for you. Sorry about that. I do like being consistent with my drawings. Whoopsies. All right, so there we go. Let's draw those electrons. If you're taking notes, I apologize. All right, so back to carbon. So carbon right here had 6 protons, so 6 electrons. 2 of them went on the first row. 1, 2, and now we have how many left? 3, 1, 2, 3, 4. 4 plus 2 equals 6, and there's 4 on the second row. So I'm going to put these in groups of pairs right here. There you go. There are my carbon atom. Booyah. Let's take a look at sulfur. I wonder if I can move this up a little bit without causing too much damage here. Yeah, I'll move that up a little bit. There we go. It gives me some more space. So let's draw out sulfur. So let's find sulfur. Here's sulfur right here. Oops. Here's sulfur right here. Sulfur is element 16. So what do we find out right away? Sulfur is on what row, ladies and gentlemen? Sulfur is on what row? That's right. Sulfur is on row number 3. Oh my gosh, you can do a better job with those circles. Come on, finish it off. There you go. Go. Row 3, which means there are 3 orbitals. And let's take a little journey. We have 1, 2 orbitals, 2 electrons on the first orbital. And then we have 1, 2, 3, 4, 5, 6, 7, 8 on the second row or the second orbital. All right, and then we have 1, 2, 3, 4, 5, 6. We have 6 on the third shell or third orbital. And there we go. That is the drawing for sulfur, right? So let's take a look at beryllium. Beryllium, ladies and gentlemen, last one we're going to do. Beryllium, this one has a charge of +2. Notice that +2. Here's beryllium right here. All right, there's beryllium. How many protons does beryllium have? Well, beryllium has 4 protons. But this beryllium right here has a +2 charge. What is that? Oh my gosh, let's go back. What does that +2 charge mean? That +2 charge means there's 2 more protons than electrons. Since beryllium always has 4 protons, and there are 2 extra protons instead of electrons, we must have 2 electrons. Mr. P, whoa, slow that down. It's okay, we've done it before. So let's take a look. I'm gonna come up here. The formula to find the subatomic particles is the charge equals the protons minus the electrons. The charge in this case was +4. Well, I'll just put 4. I don't need to put +4. It's 4. All right. All right, so the charge is 4. That's going to equal, no, sorry, the charge is 2. Oh my gosh, you guys. It's 4 protons. So the charge is 2 plus 2. The number of protons is 4. And 4 minus what equals 2? So we're going to solve for the electrons. We're going to subtract 4 from both sides. That's going to give us 0. Subtract 4. That's going to give us a -2. -2 equals minus electrons. Multiply both sides by 1. And we're going to be able to get rid of those negative signs. And so 2 equals the number of electrons. And that's how we get this. All right? So once we know that, we can say, well, beryllium is on what orbital? It's on the second. So second row, which means we have 1 and 2. Let me hurry this up. 2 orbitals. And how many electrons do we have? We only have 2 orbitals, 2 electrons. 1, 2, because there's 2 on the first row. Well, there are none on the second orbital because there are not enough electrons. The 2 go in the first orbital first. So we're going to have to come through here and let's erase this. All right, so we're going to erase this line here. Once we erase that, we're all set. And this would be our final answer. Oh my gosh. Man, this thing catches me off guard every once in a while. And this would be our final answer. All right, there we go. So that's how we would draw our shell models, ladies and gentlemen. If you have any questions, I'll be sitting right here. And hopefully you understood everything we did. I made the handout very short and straightforward because we're going to have minimum days this week due to back to school night. So have yourselves a good, enjoy the video. Hope you enjoyed the video. And I'm sitting right here if you need any help. All right. Thank you very much.